We are all in motion. Our planet pirouettes on its axis, carrying us through day and night. This world orbits a star in a stately year-long dance. Our sun itself is a traveler, one of hundreds of billions of stars swept along in the grand spiraling arms of the Milky Way galaxy. Even our galaxy is not still. It hurtles through the void, pulled by the gravity of unseen neighbors in a local cosmic flow. Everything we know is moving. But what if the stage itself, the entire expanse of space-time, is also turning? What if the whole of creation from its first fiery breath has been imbued with a subtle, colossal, and fundamental rotation? This is a notion so profound it threatens to shatter our most basic assumptions about reality, about our place within this vast existence. It suggests the universe has a hidden architecture, a preferred direction, an axis around which the entire 8-billion-year-old story is revolving, and it implies that our vantage point, our precious celestial home, is not the neutral average location we have long believed it to be. For nearly a century, our understanding of the cosmos has rested on a single powerful and elegant idea, the cosmological principle. This foundational concept declares that the universe is on its largest scales both homogeneous and isotropic. Homogeneous means it has the same basic stuff everywhere. No matter where you go, you'll find a similar density of galaxies and matter. Isotropic means it looks the same in every direction you gaze. There is no special up or down, no cosmic north or celestial east. Think of the surface of a perfectly expanding, unblemished balloon. Every point on its skin is equivalent to every other point. For an ant living on that surface, no direction is special. As the balloon inflates, all other ants appear to rush away from it, but this is true for every single ant. There is no center to the surface, and there is no edge. This principle has been our great equalizer, our compass in the dark. It allows us to apply the laws of physics we discover here to the farthest reaches of observable space and time. It is the bedrock upon which the entire Big Bang model is built. Our instruments have, for the most part, confirmed this elegant simplicity. When we peer out into the deep, we see a stunningly uniform tapestry. Galaxies and clusters of galaxies are scattered with near-perfect randomness, forming a colossal web-like structure that appears consistent everywhere. This magnificent vision of a democratic, egalitarian cosmos has guided our exploration and shaped our comprehension of all things. Yet, in the faintest whispers from the dawn of time, and in the subtle choreography of countless galaxies, a few discordant notes have begun to sound, hinting at a flaw in the masterpiece. The first clue to this profound puzzle came from a ghost. It's an echo of creation itself, a faint, pervasive glow of microwave radiation that fills the entire sky, arriving from every direction with almost perfect uniformity. This is the cosmic microwave background, or CMB. It is the oldest light in existence, the afterglow of the Big Bang, released when the universe was just 3,800,000 years old. Back then, the cosmos was a hot, dense, opaque fog of plasma. As it expanded and cooled, atoms finally formed, and light was set free to travel across space-time forever. That ancient light, now stretched and cooled by cosmic expansion, is a snapshot of the infant universe. It is a celestial fossil of unparalleled importance. For decades, we believed this background radiation was perfectly smooth. Then, with increasingly sensitive space telescopes, we found it. The CMB is not perfectly uniform. It is dappled with tiny temperature fluctuations, minuscule variations of less than 1 part in 100,000. These are the seeds of everything we see today. The slightly hotter, denser spots were the kernels of gravitational collapse that would one day blossom into galaxies, stars, and eventually us. Our modern maps of this primordial light from probes like WMAP and Planck are portraits of cosmic perfection, confirming the Standard Model with stunning precision. But these same maps harbor a deeply unsettling anomaly. When cosmologists analyze the largest patterns within these temperature fluctuations, the broadest, most gentle ripples on the cosmic pond, they discovered something that should not be there. These large-scale patterns are not randomly oriented as one would expect. Instead, they show a bizarre, inexplicable alignment. A kind of cosmic axis, a preferred direction, is etched into the very fabric of the early cosmos. Scientists dubbed it the axis of evil, not because it is sinister, but because of the terrible implications it holds for our cherished theories. This axis defines a plane that slices right through the universe. Stranger still, that plane is inexplicably aligned with the plane of our own solar system, the very path Earth traces around the Sunday. This is a coincidence of astronomical improbability. Why would the largest features in the entire observable universe seem to care about the orientation of our tiny, insignificant solar system? It's like finding a mountain range on the other side of the planet that just happens to perfectly mirror the shape of your backyard. At first, it was dismissed as a statistical fluke, a trick of the light, or perhaps some unseen contamination from our own Milky Way galaxy. Yet as the data improved and the analysis grew more sophisticated, the anomaly refused to disappear. It remains a stubborn, silent testament, a celestial fingerprint pointing to something missing from our grand narrative. The beautiful isotropic mirror of the cosmos appeared to have a crack running through it, and for a long time this was a lonely, isolated mystery. But it would not remain isolated for long. Another completely independent line of evidence was about to emerge, not from the dawn of time, but from the grand galactic tapestry of the modern age. Galaxies like our own Milky Way are immense swirling cities of stars. Many of them are majestic spiral galaxies, great cosmic pinwheels. Just as a pinwheel can spin clockwise or counterclockwise, a spiral galaxy can have a left-handed or a right-handed twist. In a universe that is truly isotropic with no preferred direction, there should be absolutely no preference for one spin direction over the other. If you were to survey 1 billion galaxies across the sky, you would expect to find a perfect 50/50 split. It's a simple coin toss repeated on a cosmic scale. For years, this was a difficult proposition to test. Determining the spin of a galaxy millions of light-years away is incredibly challenging, but as automated telescopes and sophisticated algorithms took over, the galactic census began in earnest. Astronomer Lior Shamir undertook a monumental effort cataloging the spin direction of hundreds of thousands of spiral galaxies from the Sloan Digital Sky Survey. The results were once again deeply troubling for the Standard Model. The coin toss was not fair. There was no 50/50 balance. Instead, the data revealed a small but statistically significant excess of galaxies spinning in one direction compared to the other. This imbalance was not random, it was organized. The preference for one spin direction was more pronounced in one part of the sky, while the opposite preference dominated in the opposing direction. This structure formed a massive dipole, another cosmic axis stretching from one celestial pole to the other. The universe, it seemed, was secretly playing with a loaded die. The implications were staggering. Some unknown large-scale process must have influenced the formation of countless galaxies, nudging them towards a shared orientation. What could possibly exert such an influence over billions of light-years? And then came the most astonishing revelation of all. When astronomers mapped this new galactic spin axis onto the sky, they found it pointed in a direction hauntingly similar to the axis of evil found in the cosmic microwave background. Two completely different phenomena, separated by 13.8 billion years of cosmic evolution, One from the universe's infancy, the other from its maturity, were telling the same unnerving story. They were both pointing to the same place. This was no longer a single isolated anomaly. It was a conspiracy of evidence, a growing chorus of cosmic dissent. The puzzle deepened further when we looked not just at individual galaxies, but at the grand architecture they form together. On the largest scales, galaxies are not scattered like dust. They are arranged in a magnificent, intricate structure known as the cosmic web. Imagine colossal filaments of dark matter and galaxies stretching for hundreds of millions of light-years across the void. These filaments are the superhighways of the universe, and they are separated by immense, desolate bubbles of near-nothingness called voids. Recent studies began to examine the rotation of galaxies within these filaments. What they uncovered was another layer of impossible coherence. The spin axes of galaxies were not randomly oriented within their home filament. Instead, they showed a remarkable tendency to align with the axis of the filament itself, like logs floating down a great celestial river, all pointing in the same direction. This wasn't just individual galaxies, it was entire superstructures, vast conglomerates of matter and energy, exhibiting a shared, organized motion. The coherence was seen on scales so immense they defy easy comprehension. The quiet suggestion of an underlying order was growing into a roar. All these clues, the CMB alignment, the galactic spin imbalance, the filament coherence, point toward a single radical and mind-bending hypothesis. The universe might be spinning. The entire fabric of space-time might possess a net angular momentum, a primordial rotation inherited from the moment of its birth. If the cosmos as a whole is revolving, it would fundamentally change everything. A rotating system naturally defines an axis. Suddenly, there is a special direction in the cosmos, the axis of rotation. This would immediately violate the principle of isotropy, the idea that the universe looks the same in all directions. A spinning reality could still be homogeneous with matter distributed evenly throughout, but its appearance would depend entirely on your vantage point. An observer located on the axis of rotation might see a perfectly uniform cosmos. But for anyone else, for an observer like us living somewhere off-center in this grand cosmic carousel, the view would be fundamentally asymmetric. Looking up toward one pole of the axis would reveal different patterns than looking down toward the other or out toward the celestial equator. The strange alignments and asymmetries we observe might not be cosmic anomalies at all. They could simply be the natural consequence of our off-axis perspective in a universe that is quietly, majestically turning. This isn't the first time science has contemplated such a thing. In 1949, the legendary logician Kurt Gödel, a close friend of Albert Einstein, discovered a solution to Einstein's own equations of general relativity that described a rotating universe. Gödel's universe was a strange place where time travel was possible, a mathematical curiosity that didn't expand and was therefore not our reality. But it proved that the concept of a rotating cosmos was physically plausible. What modern observations suggest is not Gödel's extreme static creation, but something far more subtle, a universe that is both expanding and gently revolving. Such a primordial spin is not a part of the standard Big Bang model. The initial explosion is conceived as being perfectly symmetrical, expanding outwards in all directions with no overall rotation. For the cosmos to have a net angular momentum, something extraordinary must have happened in the first fractions of a second of its existence. It would require new physics, perhaps, involving concepts from string theory, the collision of cosmic brains in higher dimensions, or some unknown energy field that existed before the Big Bang itself. It hints that the Big Bang was not the absolute beginning, but perhaps just one event in a much larger, stranger and older reality. The consequences of this idea, if proven true, are nothing short of revolutionary. It would force a rewrite of our most fundamental cosmological theories. First and foremost, it would profoundly challenge the Copernican principle. For 500 years since Copernicus displaced the Earth from the center of all things, science has been a story of progressive cosmic humility. We learned our planet wasn't special, our sun was just one of many, our galaxy was one of billions, and our location was unremarkable. This assumption of mediocrity is a powerful scientific tool, but a spinning universe possesses a true physical center, the center of rotation, and we are almost certainly not in it. Our view of the cosmos would be skewed by our position and motion within this greater rotational framework. We would no longer be typical observers. The universe we see would be, in a very real sense, a local, provincial view. This single revelation would reintroduce a form of cosmic specialness, not of importance but of perspective. Our address in the cosmos would suddenly matter in a way we never thought possible. This shift in perspective would also send shock waves through our calculations of cosmic parameters. The standard lambda CDM model of cosmology, which so successfully describes the universe, relies heavily on the assumption of isotropy. Our estimates for the amount of dark matter and dark energy, the age of the universe, and its ultimate fate are all derived from a model that assumes the cosmos looks the same everywhere. If that assumption is wrong, then our cosmic accounting might be flawed. The measured acceleration of cosmic expansion, which we attribute to dark energy, might be partially an illusion, a measurement artifact caused by our off-axis view of a complex rotating system. It's possible that the greatest mystery in modern physics, the nature of dark energy, is entangled with this even deeper secret of cosmic rotation. But in science, extraordinary claims demand extraordinary evidence. And the idea of a spinning cosmos remains on the fringes of accepted theory. Many cosmologists, while intrigued by the anomalies, remain deeply skeptical. The most powerful counterargument is simple and profound. We may just be the victims of a cosmic coincidence. We only have one universe to observe. We cannot run the experiment again or look at other examples. Perhaps just by random chance, the largest patterns in the CMB happen to align with our local solar system. Maybe just by a fluke of statistics in the portion of the sky we've surveyed, there appears to be a galactic spin asymmetry. These statistical ghosts are notoriously difficult to exercise. Another major concern is the possibility of systematic error. Could the observations themselves be contaminated? Perhaps the light from the most distant parts of the universe is being subtly distorted by something in our own galactic neighborhood, some foreground dust or magnetic field that we haven't properly accounted for. Scientists have gone to Herculean lengths to rule out such contamination, and so far the anomalies have survived every test. But the possibility lingers, a shadow of doubt cast over these revolutionary findings. The universe is a messy place, and our view of it is never perfectly clean. Furthermore, while the data sets we have are immense by human standards, they are still finite. Our surveys of galaxy spins, though numbering in the hundreds of thousands, have mapped only a fraction of the total sky. Is it possible that these patterns are merely regional variations in a much larger, truly isotropic cosmos? Maybe if we could see the whole picture, the asymmetries would average out, and the elegant simplicity of the standard model would be restored. These are the questions that keep cosmologists awake at night. They represent the very heart of the scientific process, a constant struggle between established theory and tantalizing, potentially revolutionary new data. The path forward is clear. We need more light. We need bigger maps, deeper surveys, and more precise measurements. Fortunately, a new generation of cosmic observatories is coming online that promises to resolve this profound debate, one way or the other. The Vera C. Rubin Observatory in Chile will conduct an unprecedented survey of the night sky, cataloging not just millions but billions of galaxies. Its data will allow us to map the spin of galaxies with a statistical power that will dwarf all previous efforts. If the galactic spin asymmetry is real, the Rubin Observatory will confirm it with a certainty that is impossible to dismiss. If it is a statistical fluke, the pattern will dissolve into randomness as the sample size grows. In space, the Euclid telescope, launched by the European Space Agency, is embarking on a mission to create the largest, most accurate 3D map of the universe. It will survey the shapes and positions of billions of galaxies, providing a new, independent check on the large-scale structure and its potential alignments. Simultaneously, new experiments will probe the cosmic microwave background, focusing not just on its temperature, but on its polarization, the orientation of the light waves themselves. This polarization data holds even deeper clues about the physics of the primordial universe and could contain an unambiguous signature of a cosmic rotation. We stand at a remarkable crossroads in our quest to understand everything. For decades, we have operated with a map of reality that is beautiful, simple, and elegant. But persistent anomalies gathered from the dawn of time and the modern cosmos suggest that our map might be missing a fundamental feature. They hint that the universe we inhabit is stranger, more complex, and less symmetrical than we ever dared to imagine. The coming years will be a time of reckoning. The new flood of data will either tame these wild anomalies, tucking them neatly back into our standard framework, or it will elevate them to the status of verified facts, forcing a complete overhaul of our understanding of spacetime. Either outcome is a victory for science. To confirm the cosmological principle with unprecedented certainty would be a triumph. But to find that it is wrong to discover that we live in a vast rotating creation with a hidden overarching structure would be a revelation for the ages. It would open up entirely new avenues of inquiry into the origins of the universe, the nature of physical laws, and our own place within the grand design. The anomalies are not failures of our model, they are signposts. They are the universe whispering a secret, challenging us to look closer, to question our assumptions, and to embrace the profound mystery of what is. The cosmos is under no obligation to be simple for our sake. Its true nature may be something far grander and more intricate than our current theories can accommodate. The quest for answers continues, fueled by the most powerful driver of discovery, the courage to confront the possibility that everything we think we know is incomplete. We listen to the static of the Big Bang's echo, we watch the silent waltz of distant galaxies, and we wait. Out there in the majestic turning darkness, the truth is waiting to be found.